So, hi everyone. Am I audible? Can someone please confirm? Okay, thanks. So, people are joining in, and I typically wait for 2 3 minutes before we start. So, I think we'll start around 3 5. People are joining in, so let's just wait for a couple of minutes and then we can start. Just wait for a couple of more minutes and then we can start. Actually, people are still joining in, so just request to everyone, please turn off their microphone during the session and only turn it on whenever you have any doubt. Ample time will be given for your doubts. If you have any doubts, ample time will be given to asking your doubts. Other than that, please turn it off. It's already 3 3. I think let's just start. Let's just start. So let me just share my screen first, and then I'll give you an intro. Please turn off your microphone. Thank you. So, are you able to see my screen? Can anyone confirm in the chat? Okay, thanks. Thank you, thank you. So let's just start. Actually, people are still joining in, so I don't know. Just a second. So let's just start. Okay, that's fine. Good afternoon, everyone. My name is Musab Rafiq. I'm your course TA for the course Digital Circuits. The course instructor is Professor Shantanu Chattopadhyay from IIT Kharagpur. I'm a PhD student at the Department of Electrical Engineering at Indian Institute of Technology, Kanpur. We carry out this TA work as a part of our PMRF duties. So before I proceed, I need to lay out some rules that we have during the live session. So in the live session, the agenda is to solve the problems that are related to the week's material, the week's contents that you have already gone through. These problems are typically based on the assignment problems, but not necessarily the same. They are not same. We can't show the same problems. But by using these problems, by covering these problems, it will help in your examination and in solving assignments. And also typically how I proceed, I typically have since it's digital, so we have 2 hour session, so I typically keep around 15 to 20 problems for one live session. And out of those 15 to 20, I have some problems that I ask you guys to solve first, then I show the solution, that are typically around 3 to 5 in number per session. And some rules are that during whenever I'm solving any problem, I won't be able to admit anyone. That's first rule, so you might be kept waiting in the waiting room. And also, whenever I solve a problem, I give 2 to 3 minutes to asking your doubt, maybe less than that, to asking your doubts. If you have any doubts, first try to write them in chat box. Most of the students were able to write it in chat box. I have been course TA for this course for the last 2 years, and this is my third time I'm the course TA for the course. So students typically used to write their doubts in the chat box, and whenever I was not able to understand their doubts from the chat box, I used to ask the student to please turn on their microphone. So microphone will only be turned on if it's deemed important. Other than that, you can always use chat box. You can always use chat box. So first, let me just admit some students, then we can start with the problem session. So any doubts before we start? Any question, any queries before we start? If yes, please type in chat box, otherwise we can proceed. Okay. And also one more information is that apart from me, there are other TAs as well. There are, I guess, 3 other TAs. So in total, we are 4 TAs. You can attend anyone's session, so there is no issue. And also, you can attend multiple sessions as well. The course recording. So before I proceed, I must tell you the session is being recorded and will be made available on the YouTube channel. The link to that lecture will be shared to you by the NPTEL team. They will share a weekly log sheet which will contain the link to the presentation and link to the lecture. So everything we made available to you guys. So let's just start. So we are here in week one, and in week one we are going to deal with the problems related to the number system, that's binary, octal, hexadecimal, their addition, subtraction, their operations as well. So the problems will be based on this number systems and introduction to the Boolean system. Now the first question of today's live session, it states that convert the binary number 1011101 to an octal number. So a binary number is in base 2 and an octal number, you must be knowing, is in base 8. So typically there are 2 ways with which we can convert this number into an octal number. First I will show you the elaborative method. So what we have here is 1011101. So this is the elaborative method, the long method. We'll first convert it into decimal number. So in decimal we'll convert it. Decimal means to the base 10, right? So how will you convert it? We'll write this number. So 2, that is a base, raised for the position and the value at that, then 2 raised to power 1 multiplied by 0. Similarly, 2 raised to power 2 multiplied by 1, plus 2 raised to power 3 multiplied by 1 plus 0, 1, 2, 3, 4. 2 raised to power 4 multiplied by 1 plus 0 plus 2 raised to power 6 multiplied by 1. Oh, sorry. I thought I shared it. Thanks for pointing out. Sorry about that. I thought I shared it. Screen is not visible. Can someone please confirm? Okay, let me just share it again. So I think I'm sharing it. I don't know. Let me just share it again. So I think I was sharing it. Admit. So yeah. So okay, writing was not visible, right? So can we just confirm? Let's just start again. So is my writing visible? Can anyone confirm? Oh, this. Okay. Let me just start it again. So we have this question: convert the binary number 10111101 to an octal number. So there are two ways with which you can do. First, I will show you the elaborative method, the traditional method that we have. So we need to convert it into the decimal number, that is the base 10. We'll convert it, but some are saying it's visible. I don't know. A student just confirmed it, right? Can anyone else point out whether the writing is visible or not? It's not visible. Strange. Should be visible. No, and now it will be, but I guess there is some problem with the, what should I say? Was it visible to some students? Can anyone confirm? Was it visible to some students before? No, not now. I'm not talking about now. I'm just talking about earlier. Was it visible to some students earlier? So let me just do it again. You guys in real time tell me whether it's visible or not. Just wait. When I will ask, then only answer it. So I'll just write the visibility test here. So do you see this visible sign? So anyone else? Are you able to see it? Can anyone else please confirm yes or no? Yes. So is there anyone who is not seeing? And please use your microphone. I'm not able to see your chats. So I think it's maybe for some it's not visible, but most of them are able to see it. So I'm writing, let's say, my name. So can you see my name? Can anyone else confirm whether they are able to see it or not? Oh, strange. Anyone able to see it? And yeah, that's the issue. But some are seeing it. I don't know why. Can anyone see my name written annotated? Anyone can see my. Is there anyone in the call that can see my name annotated? I think there is some lag. Maybe it is a lag. It's maybe a connectivity issue. That's why. So I think there must be some connectivity issues from your end, because I'm using a very high speed internet. So I think there are connectivity issues. So can I do it like this? So sorry about this. Just confirm. I need a confirmation once again. Can anyone see this? Okay, okay. So what I will do, I'll just omit the slideshow and I will draw it here. Okay, that should work. Okay, so let's start. So again, we are at this problem where we need to convert this binary number to an octal number. So what we'll do is we'll first it into a decimal number, then we'll convert it to an octal number. So we have to write its decimal equivalent. So what we'll do is we'll write 2 raised power 0 multiplied by 1 plus 2 raised power 1 multiplied by 0 plus 2 raised power 2 multiplied by 1 plus 2 raised power 3 multiplied by 1, 0, 1, 2, 3 plus 2 raised power 4 multiplied by 1 plus 2 raised power 5 multiplied by 0 plus 1 multiplied by 2 raised to power 6. So this thing will be equal to, so 2 raised power 6 is I guess 64, right? 2 raised power 6 is 64 plus 0 plus 16 plus 8 plus 4 plus 0 plus 1. So if you add them up, it comes out to be 93. Please check the calculations at your end as well. Comes out to be 93. So this number now is in decimal, but the answer required us to convert into octal. So now to convert into octal, we will divide this 93 by 8. So we have 8, 11, and that is 88, and the remainder will be 3 plus 2, 5. Then again we'll divide it by 8, and this is 8, 1, and remainder will be 3. So the number in octal will be 1, 3, 5. So the number in octal will be 135. That is option A. Another way of converting it is take the binary number and divide it into groups of 3. So 3 bits at a time. Take these 3, then these 3, and then this one. So 101 is 5. So just convert it into decimal notation. So 101 is 5. 111, so 011 is 3. 2 plus 1 is 3, and 1 is simply 1. So in this way you can also get an octal number. So any doubts with regard to this question? I think this was pretty simple. If you have any doubt, please type it in the chat box. So I guess we have already taken so much time for this question due to some technical difficulties. Now let's just proceed to question number 2. So question number 2 asks us to convert this hexadecimal number BCA16 to an decimal number system. So the number at hand is BCA. This is 16. So how will we convert it? We will take the base, that is 16, raised to power. Any doubts? Floating point next week. So whatever I have to cover is based on the week. So whatever you have studied in this week, I'll take up those problems. Floating point will be taken in the next live session, week 2. So we need to convert it into, so we'll take the base raised for the position multiplied by the value at that. So A, So let me just write here, A is 10, B is 11, so on, and F is 15. So 16 raised to power 0 multiplied by 10 coming out from the value A, then 16 raised to power 1 multiplied by C is 12, and then 16 raised to power 2 multiplied by B is 11. So this will be equal to 11 times 16 square is 256 if I am not wrong. Then we have 12 multiplied by 16, and then we have simply 10. So it is 2816 plus 192 plus 10. So if you add them up, it comes out to be 3018, and this number is in decimal. So option B is your right answer. Option B. Now going forward to question number 3. So the question number 3 asks us, this is an addition problem where we have to add two hexadecimal numbers and report the answer in hexadecimal as well as in decimal number system. So the number at hand is first BA3, sorry, like this, BA3, and we have to add it to 5TE. So we'll just add it. So I'll again write it here. So A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. So E is, what should I say, E is 14, 14 plus 3 is 17, and 17 in hexadecimal is represented by, so we'll divide 17 by 16, so it's 1, 1. So here it's 1 and 1 will be carry, right? Now A, so A is 10, D is 14, and we have one carry. D is 13, sorry, D is 13. D is 13 and we have one carry, so it is 3 plus 1 4 and 1 plus 1 2. So we have 2 4. 2 4 in hexagonal will be, so we'll divide it by 16, so this is 16 1 and remainder 8. So here we have 8 and again 1 will be carry. Now we have to do addition of B. B is 11, 5 and 1 coming out from carry. So it's 5 plus 1 6, 6 plus 1 7, and this is 1. So it will be 7, I think. So it will be 7 and 17, right? So 17 in hexadecimal system will be 1 1. So here it is 1 and here it is 1. So the answer in hexadecimal will be 1181. Now this 1181 needs to be converted to the decimal number system. So how will we do it? Just like we did in the previous problem. So we'll have 16 raised to power 0 multiplied by 1 plus 16 raised to power 1 multiplied by 8 plus 16 raised to power 2 multiplied by 1 plus 16 cube, simply because it's multiplied by 1. So 16 cube is your 4096. 16 square is your 256. Then 16 into 8 plus 1, 16 into 8. So 16 into 8 is, let me just calculate it. 16 into 8 will be 128. Then plus 1. So the total comes out to be 4481. So 1181 and 4481 are your right answers. So correct answer is option C. So any doubts in this question? Screen sharing has stopped. Is it? I don't think so. Yeah. Screen sharing is continuing. Yeah. Yeah, I know. So any doubt in this question? So just a request to the students, please join on time. So it doesn't make any sense if you join in between. Somehow I'm doing a problem in between and you guys won't be able to understand it. Week first, the difficulties of problems are relatively low as compared to other weeks. So maybe this week you might be able to catch up, but other weeks try to join. So which addition method? So simply I just did the addition, and whenever the answer was greater than 15, I just converted that number into hexagonal, and the other one is kept as the carry. So let's just say here I had what should I say? Here I had from the first addition it was e plus 3, so e is 14, 3 plus 3 is 17. So 17 in hexagonal sorry, I keep saying hexagonal, its hexadecimal system is 1 1. So 17 hexadecimal system is 1 1. So I wrote 1 here and 1 at the top, that is carry. Then there is an addition between a plus d plus 1. A is 10, d is 13, so that is 23. 23 plus 1 is 24. Then 24 is converted into hexadecimal, that is 1 and 8. So 8 written here and 1 goes to carry, and simultaneously other part was also done. Now going back to question number 4, so I have marked it in green. So by marking it, I need you guys to do it first. So I'll just give you maybe 4 minutes. That's ample time for this question. So take a pen and copy whatever you have at your place. Try to do this question and write your answers in chat box only. No need to turn off microphones. Only type your answers in chat box. Whenever you have done your question, please type it in the chat box. After that, I will show you the solution. So I think 3 to 4 minutes will be ample time for this question. Please do it. So I see some answers in the chat box. Let's just wait for 1 more minute and give others a chance as well to type in their answer. So, so let me just show you the solution. I think most of you got it correct. So the question asks us, consider the equation 1, 2, 3 in this in number system 5 equal to x8 in number system y with x and y are that are unknown, and we need to find out the number of possible solutions. So let's just convert both numbers in decimal number first. So 1, 2, 3 in decimal number will be 5 times 0 multiplied by 3 plus 5 times 1 multiplied by 2 plus 5 square multiplied by 1, and this is equal to, because we are converting both into a decimal number, so it will be equal to x y raised to power 1, that is simply y, plus 8 times y raised to power 0. Now this is 5 square, that is 25. This is 5 into 2, that is 10, and this is 3, right? And this is equal to xy plus 8 multiplied by y raised to power 0, so that will be 8 only. So we can write this as xy equal to 25 plus 30 plus 10 plus 3 is 38. 38 minus 8 is 30. Now we have this equation at hand, right? And we need to see how many possible solutions are there for this equation. So we all know that x and y are integers, positive integers. So let's just start with x first. So x is equal to 1, y is equal to 30 is one of the solution. Then the next number will be x is equal to 2 and y is equal to 15. This will be a solution. Then x is equal to 3 and y is equal to 10. This will another solution. Then x is equal to 4. We don't have an integer y that will give us the answer to 30. Then x is equal to 5 and y is equal to 6 can be a solution, but I need you guys to tell me, will this be a solution? If no, why? Why x equal to 5 and y equal to 6 is not a solution to this problem? Yeah. And how you are saying x should not be greater than 8? I mean to say greater than 6. Uh, I mean to say why you are saying this y equal to 6 is not a possibility. No, y is greater than x is a possibility, right? Because y equal to 10 and x equal to 3. So if you carefully examine the number x8, there exists 8 and y cannot be less than 8. So that's the criteria there. Y cannot be less than 8. Y has to be greater than 8. So the minimum value of y, as rightly pointed out by one of the students, is 9. So that's why we rule out this possible solution, and there are only 3 possible solutions. So the answer, as most of you had already written, is option A, 3. Now towards question number 5. So the question number 5 asks us, what will be its decimal number equivalent? So we have sorry, actually I'm getting disturbed by people are joining again and again, so sorry about that. I don't approve of this, but since it's the first class, so I again humbly request you guys to join at 3235 or maybe 36, I can that is tolerable. But in the middle of the session, I know it's first lecture, but anyways, I don't have a problem, but it will be your class ultimately. So why 5 and 6 is not a solution? So the only problem is with y equal to 6. Y equal to 6 cannot be a solution because y has to be greater than 8, and that minimum number that will be there is y equal to 9. So if you carefully look at the question, we had one number equal to x and another number equal to 8. So 8 existed in the number system. By 8 existing in the number system, y had to be greater than 8, right? So when you talk about the decimal number system 10, you have number of possibilities from 0 to 9. When you talk about binary, you have number of possibility from 0 and 1. When you talk about hexadecimal, it's 0 to 15. So it's always number of less than the base of the system, that is x is less than y. So got it? So now we need to convert this decimal number. We need to convert this binary number to its decimal number equivalent. So this is a fractional part, 111011 decimal with 0 111, and we need to convert it into decimal number system. So towards the left hand side of the decimal, the process will remain same. So it will be 2 raised to power 3 multiplied by 1 plus 2 raised to power 2 multiplied by 1 plus 2 raised to power 1 multiplied by 0 and 2 raised to power 0 multiplied by 1. And towards the decimal part we have at first 1 by 2 times 0 plus 1 by 2 square times 1 plus 1 by 2 cube times 1 and 1 by 2 raised to power 4 times 1. So this is equal to 2 cube is 8, 8 plus 4 plus 0 plus 1, and the decimal part here is plus 1 by, so we can take 1 by 2 raised to power 4 as common LCM. So please turn off your microphone, just a request please. 1 by 16, and this will be 0 plus 4 plus 2 plus 1. So it is 8 plus 4 plus 1, that is 13, plus this part is 7 by 16, right? And if you carefully look at this, this is 13.7 by 16 is equal to 0.4375. So this is equal to 13.4375. So 13.4375 is option D. So again, a request, please turn off your microphones. It disturbs the whole class. Just a kind request, please turn off your microphone. Now question number 6, it asks us to convert an octal number 205 into a binary number. So we are given this octal number and we need to convert it into binary number. So one way is to first convert this octal into decimal, then decimal into binary. That's the one way. I think you people are very well versed with that. Other than that, there is one easy method where you will take one number, one digit at a time. So one octal digit at a time, that is 5, and write its binary equivalent. So 5's binary equivalent is in terms of 3-bit equivalent. So 3-bit equivalent will be 101. 0, 3-bit equivalent is 000, and 2 has a 3-bit equivalent 010, and ultimately the number will be equal to 010000101. So we can write this as 1000101, and this is your binary of the number. So 1 Four zeros, one, four zeros, one, two, three, four, 101. So option A is your correct answer. Now I have a problem for you guys. So yeah, so question number six or five. So the problem at hand is we need to convert the octal number 205 into binary number, right? So the octal number, there are two methods. One way is you take this octal number, you convert it into a decimal number, and once you have the decimal number, you convert that decimal number by simply long division method to a binary number. Another way is you take each octal number and write its 3-bit equivalent, 3-bit equivalent, like I have taken 5, and its binary equivalent is 101. 0 has a binary equivalent, a 3-bit binary equivalent as 000. 2 has a 3-bit binary equivalent equal to 010. And I combined these three digits and I got this as the answer. I'll neglect this one because 0 at the left hand side doesn't mean anything. And finally, we have the binary number representation of the octal number. Any doubts? Okay, thank you. So this was done. So now I have a problem for you guys. I think it should not take more than 2 minutes. So you need to convert this number 1228 decimal into hexadecimal, and please write your answers in the chat box. Just write the option, correct option. No need to write the answer. Just write the correct option in the chat box. I think most of you have got the answer right. So let me just show the solution quickly. Yeah, maximum of you, most of you, yeah, most of you got it right. So let me show the solution. So we have this 1228 as the decimal number. We'll use the long division method to get it. So we have 16. 16 times 76, and the remainder is 12. Then we have 16 into 4, that is 80, 70, 64. So remainder will be 16. No, remainder will be not 16. Remainder will be 12 again. So this is 4, 12, and 12. And 12 is represented as C. So the number in hexadecimal will be 4CC. So this is your answer. I think most of you got it right. Yeah. Let me just check it again. Yeah, almost all of you. Yeah. Now we have this question where we need to do the addition operation of two binary numbers. The numbers are 110.01 and 1.011. So we need to find the answer in the binary and also in the decimal part as well. So let me just write the number first. It's 110.01 and the another one is 1.011. And the moment we do addition, it will be 1. 1 plus 1 is 2, so that is written as 0 1. 1 is carry, 1 will come down here, then it's 1 1 1. So it's triple 1.101 in binary, and in decimal it will be 2 raised to power 3, sorry, 2 raised to power 2 multiplied by 1 plus 2 raised to power 1 multiplied by 1 plus 2 raised to power 1, 2 raised to power 0 multiplied by 1, and then the decimal part will be 1 by 2 plus 0 plus 1 by 4. So it will be equal to 4 plus 2 plus 1 plus 1 by 2 and 4. So the LCM will be 4. No, it will be 8. Sorry, this is 8. So this is 8. So this will be 4 plus 1. So 4 plus 2 plus 1 is 7 plus 5 by 8. 5 by 8 is 0.625. So this is 7.625. And this is your answer in decimal. And so the correct answer is option C, 111.101 and 7.625. Any doubts here? Okay, I've seen most of you have again written the correct answer. So far we have done 8 questions. Now we'll progress to question number 9 of today's live session. So the question number 9, let me just check what is question number 9. Okay. So the question number 9 asks us, convert the number 1 to 4 in base 4 system. So this is a pretty simple question where we have the number 1 to 4 given in decimal and we need to simply convert it into base 4. So we'll use again the long division method. So we'll write 1 to 4 and divide it by 4. So 4 3s are 12 and this is 31. Remainder will be 0. Then 4 7 times is 28. Remainder will be 3. Then 4 1 times 4 and remainder will be 3. So in base 4 it will be 1 3 3 0. The number in base 4 will be 1330. That is option B. So why option C? Okay, you corrected it. Nice. Multiple choice questions are not only about whether you know things or not. Sometimes they are trick question as well. You need to be attentive. Even options are quite tricky. So multiple choice not only needs your knowledge but also attention as well. So always read question at least twice and always check your answer at least twice before marking in. So not yesterday's class. Which yesterday's class? Can you please tell me? Yesterday's TA session, live session that you had with other TA. You mean that? Yeah, there must be another live session. We don't coordinate with each other. So basically, I'm the TA for this course. I think the third time. Yeah. So this is my first session. This is my first session. Yesterday was another TA's first session. So whatever I have shown is basically from previous year's assignments or the problems that I have shown previously. So I combined all of them. So I don't know what other TAs are showing, but these are completely independent. We do our work independently. There might be some overlaps, that is natural, but that is up to you. That is up to you. That's completely up to you whether you want to attend one or both or maybe all of them. But that's up to you how much time you have. So that all depends on your time and how much you are able to extract from that. So if I was at your place, I'll pick one and then I can see the live session at my own pace. Sorry, the recorded session at my own pace and attend my live session. That is just the personal opinion. You can anyways attend how many live sessions you want. That is your prerogative. But if it was me, I'll just attend one and take a recorded session from. So basically, that will be shared. Everything will be shared in the. You won't get any. You'll get a notification. But in what will they'll do? They'll put the weekly log sheet in the NPTEL module. So you will see there a log sheet that will be shared to you very soon, where you will get the link to the live session. and also sorry, link to the recorded session and link to the Google folder as well, which will contain all the presentations from individual TAs. So when I'm done with this recording today, I need to upload it there, and the NPTEL guys will share with that with you. So don't worry, everything will be available. Any other doubt? How to get all? So please write in the chat box. So someone has written from the platform. So it is the Swayam portal where you registered, where you get the weekly contents. There they will share the link. I don't know whether they have shared it or not, but that's the usual operation they used to do. They put it there, the weekly log sheet, and you'll get that. You know that Swayam portal, where you get the recordings, the material. In that there only you'll get this weekly log sheet link. So this was question number 9. Now we can move forward to question number 10. So can you guys do this question? So here we asked to convert this 36 that is in base 7 to base 5. So I think it should not take more than 1.5 minutes. So please do it. Then I will show you the solution. So you are a lecturer and Saturday is working. So it's after 6. Saturday is 6 to 8. I'm not aware of the final exams rules. My only job is to give the live session and any information related to the live session. I'll just check it. Just give me a moment. I'll just check it. Maybe they haven't shared it yet, but they will share it. They know their work. They are completely sorted in that regard. So most of you have done it. So let me just show the solution for the recorded audience as well. So we have the number 36 that is in base 7. So what we'll do is we'll first convert it into the decimal equivalent. So this is 7 raised power 1 multiplied by 3 plus 7 raised power 0 multiplied by 6. So this is 21 plus 6, that is 27. And then 27 needs to be converted into base 5. We'll use the long division. So 5 times 5 is 25. So am I missing something? 5 times 5 is 25, yeah. And remainder is 2. Then I have 5 times 5 1 and remainder 0. So it's 1 0 2 in base 5. That is option A, as rightly pointed out by most of you guys. Now I think we can progress to question number 11 of today's live session. So the question number 11 of today's live session says that find the sum of, just a second, somebody wants to join in. So question 11 of today's live session says that find the sum of the following binary numbers using one's complement. So we have the number plus 1110 and negative 1101. So whenever we have two numbers, one is positive and negative. So if the positive number is greater than negative number, we'll take the ones complement of the negative number, add it to the positive number, and then if there is an end round carry, we will add it to the result, and we have the result. If the negative number was greater than the positive number, we'll again take ones complement of the negative number, add it to the positive number, and what we'll do, add the end round carry, and to the final result, we'll just take the ones complement. So here we have a positive number that is greater than the negative number. So what we'll do here is we have 110 as it is, that is a positive number 110. So negative 1101, we'll take the ones complement. So ones complement is simply by swapping the 1 and zeros. So wherever you see 1, you need to write 0, and wherever you see 1, you need to write 0. Wherever you see 0, you need to write 1. So 1's complement will be 0, 0, 1, 0, right? Now we need to add this to the positive number, and we have 0. 1 plus 1 is 2, so this is 1 carry. 1 plus 1 is again 2, this is 1 carry. 1 plus 1 is again 2, 1 carry. So this end round carry will be added. So this is 0, 0, 0, 0 plus 1. So this is 0, 0, 0, and round carry is here now. So I am adding. So this is 0, 0, 0 with a positive sign. So my answer will be 0, 0, 0, 1, and that is my option D. Sir, can a positive left signal be 1? No, positive left signal bit will be 0. If you use a 5-bit register system, so it will be 0. It won't be 1. So now this was question number 11. That is simply a 4-bit number, so it can be 1. Yeah, no issues with that. You are confusing with the 5-bit representation. No, here you need not to take an example. Here, a positive number is having a left significant bit 1. The one that you are talking about is the sign bit. We are not using the sign bit notation here. We are only using the addition in 4-bit. Yeah. So see, I think I went a bit quickly. So let me just spell out the steps that I have taken. So we have a positive number and a negative number, and we need to add them using one's complement method, right? So there are two cases arise when we add a positive number to a negative number. When a positive number is greater than negative number, and when a negative number is greater than a positive number. So here we have a positive number that is greater than the negative number. So when we do the ones complement addition method, so what we will do is the positive number is kept as it is. The negative number, we take the ones complement, right? So and then we add this ones complement to the positive number. So that's what I have done. 1110, and I have added it to 0010. That was the ones complement of the negative number. And ultimately I got the answer as 000 with 1 as end round carry. When I am doing the ones complement addition, the end round carry gets added to the result. That's what I have done. So this end round carry 1 got added to 0000, and my ultimately the answer was 0001, and it is a positive number. That's why I added the sign positive at the start. Is it clear, Nikhil? I guess you asked the doubt. Is it clear, or it's just a method that you have, one's complement method? So in two's complement you disregard it, but once when you are doing the one's complement addition, the end round carry gets added. So now we have question number 12. I think I have marked it green. Yeah. So this is for you guys to do first. Then I will show you the solution. So find the sum of the following negative numbers represented in a sign plus magnitude 5-bit register using one's complement. So you need to add two negative numbers in a sign plus magnitude 5-bit register using one's complement. So I think it should be done by 3 to 4 minutes, and you can type in your answer. Just write the correct option only. So when you have a negative number greater than the positive number, you take the ones complement of the negative number, add it to the positive number. You won't have any end carry there, but you need to, whatever answer you get after the addition, you need to take ones complement of that. Nikhil, was it clear? Nikhil, to you? I think you had asked this question. We don't have an end round carry, no. I'll just wait for a couple of more minutes for you guys to write your answers. Nice, most of you are getting it right. It's good. So now let me just show you the solution. So we have two negative numbers and we need to use the sign plus magnitude 5 bit register to find the sum. So we have first minus 1010. So its 5 bit representation, one's complement representation will be 1010's one complement will be 0101, and we have a negative number, so sign bit will be 1, right? Then the another number is minus 0101, so it will be 1010 with sign bit as 1, 1 because the number is negative. Now we will add them up. So 1, 1 plus 0 is 1, 1 plus 0 is again 1, 1 plus 0 is again 1, so 1, 1, and 1 plus 1 is 2, so here it will be 0, and we have the end round carry. We'll add the end round carry to here. So 1 plus 1 is 0, 1 plus 1 is 0 with carry 1, 1 plus 1 is 0, carry 1, 1 plus 1 is 0, carry 1, so here it is 1, right? Now we have the answer. This represents the sign of the answer, and this is the result for which we need to take the ones complement again. So ones complement will be 1, 1, 1, 1, and this represents your sign. So this will be negative. So minus 1, 1, 1, 1, as correctly done by most of you guys. So just a quick question: how many of you guys are UG students? Can you please raise your hands? Mm, 17. Okay. So I assume rest of you guys are working professionals and maybe something other. So 17. So nearly half of the class is UG. Okay. You guys can lower it. Yeah. Thank you. Thank you. Right. So this was question number 12. So somebody has asked. No, yeah, I got 1000 answer. One is my sign bit, and the answer was from the complements. I need to again take the complement of the answer. So that case was only true for when the positive number was greater than the negative number. When both numbers are negative, the final answer needs to be complemented again. That's why I got the answer 11111. So I suggest, Nikhil, I think you have some doubt in the ones complement addition. I suggest you carefully go through lecture pertaining to this again. If you still have any doubts, we can discuss it next time. There are basically rules you need to follow when the positive number is greater than negative, when the negative is greater than positive, and both are negative. You need to follow certain set of rules, right? It's simple. I think you are getting a bit confused, but it's simple. Trust me. Yeah, recorded session will be available for all sessions. All sessions, recorded session will be available. It will be shared to you. After I'm done solving this today's live session, during the course of the session, I'll just check whether they have uploaded the weekly sheet link or not. Most probably they'll share it with you as soon as possible. Maybe it might be even there, but I'll just check it and let you know. So let's just move to question number 13. In a 5-bit register, find the sum of the following. Now what we need to do, we need to use 2's complement, right? So far we were doing 1's complement, now we need to do 2's complement and find the sum. So here what we have is, we have a positive number and a negative number. Positive number is less than the negative number. So we'll take the positive number, that is plus 0011, and its 5-bit representation will be 00011. Then we have a negative number 0101. It's 2's complement. So how we find the 2's complement? We'll first take the 1's complement and add 1 to it. So this is 0101, 0101. Its 1 complement will be 1010, and for 2's complement we'll add 1 to it, so it will be 1011. So it will be 1011 with sign bit as 1 because it's a negative number. Now we will add it. So 1 plus 1 is 2, so 0 and 1 carry. 1 plus 1 is 3, 1, 1. This will be 1, this will again be 1, and this will be 1. Now what we need to do, we need to take the 2's complement of our answer. So what we'll do is, we'll first take the 1's complement, that is 0001, and add 1 to it. So this 1 comes out from that, basically once we have first taken 1's complement, and for 2's complement we need to add 1 to it. So it will be 1 plus 1 is 0, this will be carry 1, so it will be 00. So this is the magnitude of my answer, and sign bit is negative, so this will be minus 0010 is my answer. I'll again go through it. So option C is correct. We have a 2's complement addition for the positive number and negative number. Negative number is greater than the positive number. So what we'll do is, we'll take a 5-bit register for a positive number and write the number as it is with the sign bit equal to 0. Then we have a negative number. We take its 2's complement. How we find the 2's complement? We first find the 1's complement and add 1 to it. So the 1's complement for 0101 was 1010. and then we added 1 to it, and we got 1011. So here towards the right hand side of the screen top, then we added the two numbers. We got the result as 1110 with 1 as a sign bit. To the result 1110, what we'll do is we'll take its two's complement. How we'll find the two's complement? As I said it earlier, we'll take the one's complement and add 1 to it. So one's complement was 0001 and added 1 to it. So my magnitude of the answer was 0010 with sign bit as 1. So that means negative. So the answer was minus 0010. So am I going fast? Okay, sorry about that. Sometimes I get carried with the flow. So should I repeat it or okay? I think I repeated it. Yeah. Even I felt quickly. Please, if in future I go to I'm moving fast, please let me know that time only. That will be very helpful. Based on the question, you should always do whatever the question asks. Two's complement, because the method is two's complement, right? Whenever you are doing addition using two's complement method, you need to you started with the two's complement, and you also need to do two's complement. Now this was question number 13. Yeah. Now somebody has written D. I guess your doubt was cleared, right? Okay, let's move to question 14. These are a couple of questions that I want you guys to do. I think it should not take more than 2 minutes. So this is the number you have at hand, binary number 101010, and you need to find its equivalent decimal number. So please do it. So these type of questions you need to do quickly. You need to get a lot of practice because in future, maybe in some bigger problems, this might be a smaller step, but at that time you should be able to do it quickly. So in a bigger picture, the smaller steps will be done quickly. That's why these are very simple question. I know, but you should practice them as well. This is the time because week one is slightly on a easier level. You should be able to you should be familiar with this Boolean system, addition, subtraction, and all. That's why. Okay, and let me just show the solution quickly. So we have 1 0 1 0 1 0, and its binary decimal equivalent will be, so it will be 2 raised to power 5 times 1 plus 2 raised to power 4 times 0 plus 2 raised to power 3 times 1 plus 2 raised to power 2 times 0 plus 2 raised to power 1 times 1 plus 2 raised to power 0 times 0. So we have 2 raised to power 5, 32 plus 0 plus 8 plus 0 plus 2 plus 0. So ultimately we have 42. That is option B. Now I have another question for you guys. So we have the decimal number 76. Find its the hexadecimal system equivalent. It should not take them more than 1 minute. Within 1 minute, you should be able to do it. Maybe even less than that. Most of you have got it right. D. So we have 76, that is in decimal. So to get it in hexadecimal, we will divide it by 16. So 16 4 is 60, 16 4 is 64. So remainder will be 12. So this is 4 and remainder will be 12. And 12 in hexadecimal is C. So the answer is 4C. Now I have a question that is based on conversion of an octal number which is in fractional. We need to convert it into, based on the options, hexadecimal. So see, in the question, that is a statement. No number system was given, but you can look at the options. So all of the options are in hexadecimal. So we'll have to convert this number into hexadecimal number system. So how will you do it? There are two ways of doing it. One way is first convert the octal into binary number by taking 3-bit equivalent of each digit and writing its binary, and then converting that binary by taking 4 bits at a time and writing its hexadecimal. So what I mean to say is write 651.124, take one digit at a time and write its 3-bit equivalent. So right now it's in octal. So once 3-bit equivalent is 001, 5 3-bit equivalent is 101, and 6 3-bit equivalent is 110. Then towards the decimal part, 3-bit equivalent is 001, 2 is 010, 4 is 100, right? Now take 4 bits at a time. Here 4, here 4, and this. And also from here 4, here 4, and this. So this you can neglect. Towards the right hand side of the decimal, all the zeros can be neglected after the last bit. So this is 0. So this is 1001. So it's the hexadecimal equivalent. It's 8 plus 1, that is 9. So this is 9. Then this is 1010. So 8 plus 2 is 10. So this is A. And then we have 1. So this is 1 in 9. Then the decimal part. So 0010 is simply 2. 1010 is simply 8, that is 10. 1010 means 8 plus 2 is 10. So 189.2a is your answer. But this was the shortcut method. I call it a shortcut method. Just a second. I call it a shortcut method. Now, the traditional method would have been to first convert this number into a decimal number. So 6 multiplied by 8 times 2 plus 6 plus 5, sorry, plus 5 multiplied by 8 times 1 plus 1, simply. I'll just skip that part. And then we have the decimal part. So this is 1 by 8 times 1 plus 1 by 8 raised power 2 times 2 plus 1 by 8 raised power 3 times 4. So we have 384. I'm just skipping some math part here, which you can cross check at any time. 384 plus 40 plus 1, and the decimal part will be equal to plus 1 by 8 plus 1 by 8 square plus 1 by 8 cube. So decimal LCM will be 64. This will be 8 plus this will be, sorry, 64. Oh, how is it 64? Okay, it's 8 cube. It's 512. This is 512. This is 512. So this here is 64 plus 16 plus 4. So my decimal will be 425.64, sorry, 425.164, 425.164, 0625. So this huge number is your decimal equivalent. Now I have a question for you guys. Can you convert this decimal number to hexagonal? If yes, do it. Can you convert this decimal number 425.1640625 to hexadecimal and check whether the answer comes out to be same? Can you guys give me confirmation whether you got the correct answer and whether you are able to convert this number, decimal number, to hexadecimal number? Yeah, in hexadecimal, correct. That is base 16. Were you able to do it? No. So 425 can simply be converted into hexadecimal by long division method. So when you take 425 and divide it by 16, you get your answer as 189, 1A9, sorry, 1A9. Now comes out the fractional part, that is 0.1640625. How you convert it? So you take this part, so you write 0.1640625 and multiply it by 16. Once you multiply it by 16, you get your answer as 2.625. You take the integer part, keep it aside, and now take as 0.625. Now you take this 0.625 and multiply it by 16, you get 10. That is A. So your decimal part was 2 and A. So the answer was 1A9.2A. You can check it. This is kind of a home assignment to you. The students who are not able to do it, you can do it at home, at your workplace. Now comes question number 17. This is a simple question. This asks us, when two n-bit binary numbers are added, the sum will just a second, some students want to join. So the question is, when two n-bit binary numbers when two n-bit binary numbers are added, the sum will contain maximum number of, this is simple question, it will contain a maximum number of n plus 1 bits. So for example, we have two-bit numbers. So this is 1 plus 1 is 1, 1 plus 1 is 1 plus 1, and 1 will be carry. So at maximum, it will always be n plus 1. If you take 3-bit numbers like this, it will be 1 plus 1 will be 1, it will be 0, it will be 1, it will be 1, and this will be 1. So always it will be n plus 1. So option D is the correct answer. Now we have question 18. It states that if 110 in base system X is equal to 132 in base system 4, then what is the value of X? So this can be found out by simply converting both of the numbers in the decimal number system and then solving the equation. So what we do is we'll take 1, 1, 0, 1, 1, 0 x, and this thing is equal to 132 in base 4. Now this is x raised to power 0 times 0 plus x raised to power 1 times 1 plus x square times 1 equal to 4 square times 1 plus 4 times 3 plus 4 raised to power 0 times 2. So this thing will be equal to x square plus x equal to 4 square is 16, 4 times 3 is 12, and this thing will be equal to 2. So this is equal to x square plus x equal to 16 plus 12 is 28, 28 plus 2 is 30. Now simply it's just solving a quadratic equation, x square plus x minus 30 equal to 0. Let's split the middle term, so we can write x square plus, so the product is minus 30 and the sum is x 1, so it will be plus 6x minus 5x minus 30 equal to 0, and we have x plus 6 minus 5 times x plus 6. So ultimately x is either minus 6 or x is equal to 5. So the base cannot be negative. The only solution is x equal to 5, option B. So I see some of you have already written the answer. That's nice. So far we have done 18 questions. Now the last two questions are again the question I would like you guys to do first, then I'll show the solution. So question 19 states that consider the equation 7526 in octal number system minus the number y in octal number system equal to 4364 in octal, and you need to find out the y. So do it. It should not take more than 2 minutes. Also a request. So maybe you can. Some of you might be knowing that I haven't admitted a couple of, I don't know who they were, students in the call because their name, that is a name that appears while joining the meet, was not appropriate in a way that it doesn't signify a student's name. So I know some of you are using a dummy accounts and all, I can understand, but at least it should carry a real human name. I won't consider any participant having a dummy name. So you can use, if you don't want to reveal your identity, I have no problem with that. But at least a human name, please have a human name. I will not consider any dummy name or gaming names. So I haven't admitted a student. I don't know whether that person was a student or not, but I haven't admitted a student with some gaming name, to be precise. So perhaps the We have a split audience on this question. Some say C, some say D. Oh, we have a A as well. So let's just break the suspense and look what the answer is. So we have a number 7526. So basically this is A minus B equal to C and we need to find B. So B will be simply A minus C. So 7526 minus Y was equal to 4364. That implies Y is equal to 7526 minus 4364. Keep in mind both the numbers are in octal. So we will write 7526 subtracted by 4364. 6 minus 4 is 2. All of you got it right. Here there is a trouble, right? So this is 2 minus 6. So if you are doing a decimal subtraction, we would have taken a borrow, right? In decimal number system, we take borrow, that is equal to 10. But right now we are operating in an octal number system, so the borrow will be 8. So it will be 8 plus 2, that is 10. And we have to subtract 6 out of it. So 10 minus 6 will be 4. So most of you got it wrong because they took considered it as 12. 12 will only be possible in a decimal number system. Here we are operating in octal number system. So the borrow was 8. 8 plus 2 is 10. 10, 12 minus 6. Sorry, 8 plus 2 is 10. 10 minus 6 is 4. Now this is 4. 4 minus 3 is 1. And this is 7 minus 4. That is 3. So 3142 in octal number. Option C. Yes, exactly. Plus 8 we need to add. To those who wrote A8, I hope your doubt got cleared. Yeah? Sorry? Yeah, sure, sure. So we have the equation 7526 in octal minus y, that is also in octal, and the result of this subtraction is equal to 4364, right? Now we need to find out the y. So 7526 minus y is 4364 and y will simply be equal to 7526 minus 4364. So here I have 7, here I have 5, here are 2 and 6, and here I have 4, 3, 6, 4. 6 minus 4 is 2. Now we need to subtract 6 from 2. To do that we need to borrow, but we are operating in octal number system. The borrow will not be 10. It's not like a regular subtraction that is in decimal where we borrow 10. In binary we borrow 2. In octal we borrow 8. So it's 8 plus 2, that is 10. Now the number that there exists is 10, and from that 10 we are subtracting 6. So 10 minus 6 is 4. Now since we have taken a borrow, this 5 will become 4. 4 minus 3 is 1. And finally 7 minus 4 is 3. So the answer to my question will be 3142 in octal number system. Is it clear? Thank you. And to the last question of today's live session, I have a question for you guys that states that the number 1102 in base 3 is equivalent to 123 in which base system? So I'll give you 4 to 5 minutes. Please solve it and write your answers in the chat box. Well, that was pretty quick for you to write D. Anyways, let's see what other guys write. Most of you are writing the correct answer. I'll just wait for other guys to solve it as well. So let me just show you the solution. So the question asks us to find the equivalent of 1102 in base 3, which has the equivalent 123, but we need to find out the base of the number system. Basically, this is analogous to the previous question, just that previous to previous question, sorry, just that 1102, you will write it like this. So someone has turned on the microphone, just a request, please turn it off. So please turn off your microphone. If you guys are at least, some of you guys are just joining for the sake of it, please at least keep it in on the mute. It disturbs the other participants who are concentrating as well. So you need to find x, simply x. So we have 3 cube, so 3 raised to power 0, 1, 2, 3 cube plus 3 square plus 3 raised to power 1 times 0 plus 3 raised to power 0 times 2 equal to x square plus 2x plus 3. So this is 27 plus 9 plus 2 equal to x square plus 2x plus 3. And we have 27 plus 2 is 9, 29, 29 plus 9 is 38. So this is 38 equal to x square plus 2x plus 3. So you have x square plus 2x minus 35 equal to 0. Again splitting the middle term, sum is 2, product is minus 35, so it will be plus 7x minus 5x minus 35 equal to 0. Ultimately this will be equal to x plus 7 and x minus 5, and x will be equal to 5 and x will be equal to minus 7, but base cannot be equal to minus 7, so the solution is B. Option B is the right answer. So this was all for today's live session. So what I'll just do right now, I'll just check the Swayam portal. Okay, okay. Yeah, I'll just go there. Slide 15. Question number 15 or slide 15? Slide, this one? Slide 15. Okay. I should write the page numbers as well. So slide 15. Oh, yeah. Hmm. Okay, good. So what I will do is I'll just check that Swayam portal first. Just give me a second. I'll just check it. I don't know whether they have shared it or not. So, week two feedback from digital surveys. Digital. I don't think they have shared it with you as of now. I'm not able to find it as well. But I think once the sessions are done for week one, I think you have the session one, two, I think problem solving session Sunday and Saturday. Saturday session two. I think there were four TAs as far as I know. Yeah. So July 30. July 30 will be the last session. Saturday there are two sessions, right? Saturday there are two sessions and Tuesday is last. Maybe in coming week they might share it. So you'll find everything there. So as of now I'm not able to find it. I think they haven't shared it. But once they will share it, it will be there for the whole sem. So you don't have to worry about it. They'll share it. I think in 2 3 days they will share it. So any other question, query, please let me know. If not, we can. That's all for today's session. I think. Yeah, I was saying that only, right? They'll put on YouTube. I think if you will type in my name, you will find the lectures of previous 2 years, and this lecture will also be uploaded in half an hour. But NPTEL team will share with you the Excel sheet that will contain links to all YouTube lectures from my side as well as the other TAs as well, and also the course material will be present there. It will be shared I think within couple of days. They will share it. Any other doubt? If not, I'll thank you all. Okay. So I thank you all for joining. Hope to see you next time at the same time, Sunday 3 to 5 p.m. Thank you guys. Thank you guys for joining.